And that's a translation. So reflection, we flipped over a line. Translation, we slide up, down, left, right, and a certain amount of units every time. That was for what? Reflection. And that was the only thing that was for reflection. Good news, there's 3 different ways to write a translation. And even better news, yes, I want you to know all 3. All right, 3 different ways to write a translation. A slide is happening. First one, function notation. Here's what function notation looks like. It always starts out with x comma y. Always will start out with x comma y. And then you'll see our little implies arrow. Remember writing those? Huh? It's been how long since we've done proofs, huh? Oh, don't worry, Unit 10, we're coming back strong. And then you'll have a second set of parentheses in function notation. That's the most important part. That's going to tell you what's happening to your x and what's happening to your y. So let me throw x minus 3 in there and y plus 2 and talk. What this is telling me right now, you're going to subtract 3 from every x coordinate, add 2 to every y. Where's it going on the graph then? If I'm going to subtract 3, give me a direction we're going. X minus 3. Where are we going? Left 3. So every point's going to get moved left 3. And then what do you think here with y plus 2? Up 2 units. Okay. Every point. Same direction, left 3, up 2. Second way I could write it, a little bit more compact, vector notation. Instead of parentheses, and I don't know why they chose these, but you're going to see these, the old inequality symbols there. Inside, you'll see 2 numbers. Means the same thing as function notation, left 3, up 2. I just write it a little differently. Function, responsible for. Vector, you're responsible for. And then honestly, I've never seen a name for this next notation, so I just put other. Lowercase r for reflection, capital T for translation. And I already got the question. You got to put the fangs on there? I don't care. That's how I roll with my capital T. I throw the fangs on there. All right, you don't have to if you don't want to. It's missing something, isn't it? I know it's a translation by the capital T. What else do you have to know then? Where are you moving, right? And where do you think that's going to be located? Same place it was for the reflection. Subscript. -3, +2. All 3 are a translation. All 3 are in the same direction. And yes, I need you to be responsible for all 3. Because here's how it's going to go Friday's quiz. Write this translation in function notation. I should have known all 3. I should have listened to it. All right, I'm going to have you leave it in a specific type every time. It's not going to get to choose. All right, so we all good with translation, direction, distance, up, down, left, and right. All right, first thing, you guys have to understand when a translation happens because everyone just looks at these 2 and go, oh yeah, I slide it right and down. I'm good. No. You have to slide it the same distance and the same direction for all the points. All the points. So I have A, B, C, D here. Square, yep. Square, A, B, C, D. What do I call this, by the way? My original one? I want to use some vocab. Pre-image. And I went to the primes, which is called my image. I want to know, did I actually do a translation? So in your group right now, you're going to go from A to A prime, B to B prime, C to C prime, and D to D prime and say, am I going the same distance and direction for all 4? If it's 3 out of 4, that's not a translation. That's something else. But it's got to be all 4 points have to match up with the same distance and direction for each other. And remember, you got to go pre-image to image. Pre-image to image. So is this a true translation, or am I just first problem of the day, just trying to mess with your mind? What'd you find out? Same distance, same direction? All right, so is this a translation? Yes. How do you know? All points move. Same distance and what's the other key piece? It's got to move the same distance and direction. Yep. Last part. Describe it then. Now actually put some numbers in front of your proving here. How many units? Up, down, left, and right. Talk to me. How do I move it? Woo! 15. Only one absent. And it comes up. 3.
6 to the right and 3 down.
6 right, 3 down. Everyone like it? All right, here you go. Let's describe it. First way we could describe it, using the capital T. How do I write 6 right? Positive 6. How do I write down 3? Minus 3. Or, and yeah, I'm going to be that guy right now just to make sure. Vector notation. How do I write that in vector notation? Make sure we get our symbols there with 6, negative 3. Or, yep, let's put function notation down. And again, if you feel like you only put 1, good, you're going to get burned on Friday. Function notation. Got to start with x comma y implies every time. X comma y implies. And then what are you going to put in the second one? Look up above. Look up above at the example we did for function. What are you going to put inside your parentheses here? Oh, 7.
X plus 6.
Yep. Got to have the x and the y attached. Good. Perfect. Any questions? So I want to move here so you guys have enough time to finish and don't have any assignment for tonight. All right, let's do a translation to an actual triangle. We reflected triangles the last 2 days. Let's translate one. 2, 1. 3, 3. And negative 1, 3. And translate it along the vector negative 4, 1. So somebody, before we even start, what direction and distance am I going? Negative 4, 1. Where are you going? 4?
To the left and then up 1.
Good. Left 4, up 1. 2 ways you could do this. You could actually just physically move it on your graph, left 4, up 1, or if you want to do it without using the graph, just take all your x's, subtract 4. Take all your y's, add 1. That's the other way you could do it to find the new points. So either physically move it left 4, up 1 on the graph, or take all the points, subtract 4 to the x's, add 1 to your y's, and they're your new ones. What are you calling your new points, by the way? Primes, right? Primes. Let's not get out of that habit. A prime, B prime, C prime. Go ahead, do your magic, and I'll ask somebody for these coordinates here when I'm done graphing. Oh, left 4, 4, up 1. There you go, up 1. That's it. I'll get it eventually. Coordinates, what do you got for me? Coordinates of my new triangle. 21, A prime.
-2, 2.
1 for 1, Dan. Let's go. Don't screw it up.
Negative, or for B, -1, comma 4.
All right, the clincher. Let's roll.
-5, comma 4.
Good. Okay, everyone's all good? All right, one more, and then I'll do something different at the end of this one. New notation. Everyone sees my new notation here, my other notation. I still see a capital T, so that tells me translation. 3, -1. Somebody hook us up. Where are we going? What direction and distance? 28?
Right 3 down 1.
Good. Right 3 down 1. So go ahead, do your magic, and then we'll do part C together. Hey, how about those coordinates when you get them? When you're ready, throw the coordinates at me here. 28 again. No, I need somebody else, Tyler. No offense. 23.
A prime is 0, 3.
Yep, go ahead.
B prime is -1, -2.
You better finish here, Maddie.
And C prime is 1, 0.
There you go. Told you not going to be a bad day. Part C now. Ready here, honors kids? Draw the vector that defines this translation, right 3 down 1. All right, well, first, let me introduce you to what a vector looks like. You guys remember probably Unit 1, array, what array look like? That's what a vector looks like. Okay, that's what a vector looks like. But you can't just draw any looking ray you want. It's got to follow right 3 down 1. So what I need your help with is, on this graph, I need to draw a ray that says you're going right 3 down 1. So I'm going in this direction, this distance. I need a ray that tells us, oh, we're going right 3 down 1. Look at what you've just done on the graph, too. Anybody see where I could possibly make a ray that definitely says you went right 3 down 1? Take a look at take a look at what you've already done on the graph. Is there anywhere I can draw a ray in that says you go right 3 down 1? Think about it. And there's unlimited answers here. So, but I thought maybe just by looking at the graph, you could say, oh, if I do this, that shows I'm going right 3 down 1. Thoughts? I don't want to call on anybody here. This is a tougher question. Dylan?
In between 2 of the points, like A prime and A.
So you're basically saying take A to A prime. Ready? Here, 2. Because what'd you do to get from A to A prime? You went right 3 down 1. So you can connect any point to its image. Or if you're feeling real saucy and just want to show off, just pick a random point and go where? Right 3, down 1. There you go. So it can go anywhere on the graph. But probably the easiest way is just to connect 2 corresponding points. Yep, good, good. So that's a vector. Shows you the direction and distance you're going. All good? All right, a little, I don't know if this is going to be tricky for you guys, but let's go backwards. So here's what I'm doing here. I went from 3-3 to 6-1, and I'm telling you it's a translation. So you guys know automatically I must have gone up, down, left, or right. 3-3 to 6-1. Whatever that rule is, I want you to apply it, but look at the directions. Find the pre-image. So for part A, I ended up at 8.3. Using this rule, where did I start to end up at 8.3? See the directions there? Where did I start? What was the pre-image? And then using the same rule again, where did I start to end up at 2, -5? So go ahead. You can use your group members here for this one. It might be a little tougher. We'll see. You got to find the rule first. What was the translation rule, and then apply it to A and B. But remember, I need to know where you started, not where you finished. I know where I finished. If there's arguments, discuss it out, hash it out.
Second one. -1, -1. Not minus -1. -1, 2.
What?
Yeah, I got -1.
Up to
Wait,
Is it 3?
no, this -3. I'm an idiot.
I
for
did.
the y-axis. That one negative.
No, you have to find the page. These are what happen.
First thing, what's the rule? 3.3 to 6.1. What are you doing? 22. What are we doing from 3.3 to 6.1?
You're going to right 3, and then you're going down 2.
All right. So there's the rule. So where must I have started? And then I would have gone right 3, down 2, and gotten to 8.3. That's what I need to know. Where'd you start then? Ho, 13.
For A's,
5, 5. Yep. For part A, 5. I must have started at 5, 5 to get to 8.3. And then same thing, part B. I went right 3, down 2, and I ended up at 2, -5. Where did I start then? 11?
-1, -7.
Okay, if I go -7 and down 2, where am I going to end up?
Oh, -9.
-9. I got to end up at -5.
-1, -3.
All right, there we go. -1, -3. Good. All right, and then we'll end class here on probably one of my top 10 examples of the entire year. A little band camp, huh? Little band. Anybody involved? Who do we got involved here? A little band. I call it band camp, but anybody involved here? Band camp? Not that you've gone to band camp. You're involved in band. Where do you play?
flute and piccolo.
Wow, piccolo. Is that like that's an actual school instrument? No, I'm not dismissing it. I just never knew that. Nice. How long you been doing it for?
Like I've been playing flute for like 4 years. I started playing this year.
Why'd you pick that up? Never, but why though?
Because he needed a player. So like, alright, I'll do it.
Team player, good. Sky, what do you got?
Percussion.
How long have you been doing that?
4 years.
I just got 2. Bridger,
I play trombone.
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 Nice. How long?
Since 5th grade.
Wow, you're a lifer.
Yeah.
Started from the beginning. Nice. Lifers in here, good. Anybody else?
I play flute.
Since 5th grade?
Yeah.
Nice. Anybody else?
Anybody?
I just asked because I envy you guys because I have had zero musical talent. I don't know. I think I told you, correct? My musical experience started and ended in 5th grade with the baritone. Yep. I was so highly ticked off that I didn't get the drums and ended up doing baritone. It was awful. Awful. So that ended in 5th grade. That's it. So good. All right, so back to our band camp question here. And if anybody needed help, I told you we're right, left, forward, and backward because I knew people I'd be working with here. So if you guys need help there. First question. How do I get from position 1 to position 2? And I want you to tell me in 2 different ways. Words and writing it in function notation. So how do I get from position 1 to position 2 in words? I'm going to ask for words first, and then we'll transition to function notation. You better be careful. Anybody observing here my graph? It's not your usual graph. Why not? Yeah, I know there's band people on it. Thanks. But anybody see how it's labeled? How's it labeled then, Superstar?
It goes in increments of 2s.
That is absolutely correct. Look at that. Good job. Yes, everyone noticed it goes by 2s. I'm sorry, I shouldn't act so surprised. I should have known you would have known that. Yes, everyone's saying it goes by 2s, so be careful when you tell me in words. You're going by 2s here. So that's the first thing I'm going to ask. Somebody tell me in words from 1 to 2. Oh, trumpets. I never knew that. I never saw that one. Trumpet line. All right, what do you got for me? In words, how do I go from position 1 to position 2? 17. Where am I going?
Oh, in words.
Yes.
You're going to the right or to the left
10?
Yeah. Isn't each space? Oh, 12.
12. You sure?
Yeah.
Okay, yeah. Left 12. Am I going up and down at all, Riley?
Up to. You're going.
I wasn't trying to trick you or anything. I'm just left 12 and then they match up, right? I don't need to go up or down. That's what I'm asking. Right? I don't need to go up or down. And I may make a point of this. It's okay. You may not go left or right. You only may go up or down. You may go one in direction, not both. So left 12, and that's it. Left 12. All right, let's put this bad boy in function notation now from the beginning of the class. All right, function notation. Got to have x comma y implies. How do you take care of the left 12 part? How do you take care of the left 12 part? What do I write in first here? Oh, 2. X minus 12. And since we didn't go anywhere on the y, or if you want to put plus 0, minus 0, you're trying to show off, but not really. It's fine. It's correct. All right. But y is certainly okay as well. All right. Last one. Let's go from 1 to 3 now. 1 to 3, but put it in a translation vector. Go from 1 to 3, put it in a translation vector. Remember, you're going by 2s. All right, think we got it? Finish this on a good note. 1 to 3. 5.
Negative 12.
Left 12. Because that's how we got over to position 2. And then I had to go down how many, Claire? Sorry.
9.
Down 9, so minus 9. Good work. Good work. Look at the bottom of your packet right now. Bottom of your packet. 5, 6. Graph, not optional. Not optional. 18 to 19? Yes, it is optional. And then finally, 23 to 24, you're going to see a graph that has a blue and a green figure on it. But there's no directions in your textbook how to write it. So I'm telling you, I want the translation rule going first from the blue, then to the green. Okay, so blue to green, what am I doing? Left down, up and right. Okay, let's get rolling. Let's get going. Definitely can just finish this up here. I think I'm gonna have to copy more slices there. Can somebody, Zach, pass me a slice here so I can go copy some more right now.